Okay, I promised you a good last lesson in Chapter 8. Here it is, called Linear Programming. And I put it on the board ahead of time just to save you a little bit of time. So I made up this example. There are real-life examples that are more complicated, but which are very important ways, very cool ways to find the optimal solutions for things using lines, basically. So here's my example. Suppose you have a baker who has 24 pounds of flour and 28 pounds of sugar. Okay, so this could maybe be the amount of material that comes in every day or something like that. So he's got to make some choices about how to use it. And he makes two kinds of cakes. He can make a graduation cake, and a graduation cake uses 3 pounds of flour and 1 pound of sugar. And he also makes wedding cakes, and wedding cakes take 2 pounds of flour, and of course you have all that frosting, so it's 4 pounds of sugar. Okay? And so depending on the price of these cakes, he has to decide how many of each one should he make. He can't make 50 of both because he only has that much sugar and flour left. So he's got to figure out the optimal solution. So this is kind of a cool problem, okay? A nice example of how to use lines. So here's where we always begin again, right? We begin with the word let. Let X be the number of graduation cakes that he makes, and let Y be the number of wedding cakes that he makes. Okay, you always have to begin by you reach into the real world and you turn it into a mathematical problem by making these choices here, by assigning those variables. Now, as soon as you do that, you can start saying some things, because what do we know? There's only 24 pounds of flour. So every graduation cake uses 3 pounds of flour, and every wedding cake, there's the number of wedding cake, uses 2 pounds of flour. So there's the total amount of flour that he uses for the graduation cakes. There's the total amount that he uses for the wedding cakes, 2 pounds for every cake. So you add those together, and that all has to be less than or equal to 24, because you only have 24 pounds to begin with. Make sense? Similarly, looking at the sugar, every graduation cake uses 1 pound of sugar, and every wedding cake uses 4 pounds of sugar. So 4 times the number of wedding cakes plus 1 times the number of graduation cakes. There's your total amount of sugar. That has to be less than or equal to 28. So those are called your constraints, and we need to graph those. So notice that if those were equal signs, I would just have a couple lines to graph. And again, I've done this all kind of ahead of time, but you can graph the lines easily. If you were to graph this one, you can let y be 0 and x would be 8. And if x is 0, y would be 12. So there's your line, there's your L1 right there, line 1. How about line 2? If x is 0, y would be 7. So this is L2 right here. And if y is 0, x would be 28. So it's way out there, okay? 28. So, going back to making these inequalities, how does it change when you have an inequality rather than an equality? And this line here, equality, is the actual line. If you have an inequality, that means you're on one side of the line or the other. What side are you on? It's easy enough to figure out. Just choose any point and see once if it's accurate. If you take 0, 0, there's an easy point. There's the point 0, 0. Is it true that 0 times 3 plus 0 times 2 is less than 24? Less than or equal to 24? Yeah, of course. 0 is less than 24. So it must be this side of the line. So one constraint is that in order to fulfill this condition, these are all the points. Obviously, x and y all have to be positive. It doesn't make sense to have negative 2 pounds of flour. So all those points in there are all the points that satisfy this condition right there. Similarly, we find all the points that satisfy this condition, and you can see how you're going to do it. It's all the points, again, that are under the line, under or on the line. It's less than or equal to, so that includes the line. So that's going to be, let me do that one in blue. So that's going to be all those. So both of those inequalities have to hold at the same time. You have only this much flour and only this much sugar, so you have no choice but to have both of those things hold, which means we have to be under this line and we have to be under this line. So this is the region right in here of all the choices he can make of what do you call it? Of wedding cakes and graduation cakes. Okay, so what are all the different possibilities? Well, I've got them actually kind of written out here. Here's the different possibilities. He could make 0 of each. That's certainly possible. He could make 1. Let's see. X is the graduation cakes. So he could make 1 graduation cake and no wedding cakes. That's certainly possible. He's not maximizing things, but he's got all these different possibilities there for making 0 wedding cakes and this many graduation cakes. Okay. What other possibilities does he have? He could make 1 wedding cake and 0 graduation cakes, or 1 of each, or 2 graduation and 1 wedding. All these are possible. 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. And here we have 7. There's 7 that are possible in there. Okay. How many possible do you have here? All these points right here are in there. There's along with this one, there's that one there, and then there's 6 more that are all. What's this? This would be 6 graduation cakes and 2 wedding cakes. He could do that. If he wanted 7 graduation cakes and 2 wedding cakes, nope. He doesn't have enough of the flour to do that. He'd be outside of that constraint. Okay, what are the other options? There's the other options. Okay, this one is right on this line, in fact, right there. I got them all kind of listed out. You got there. And this one is outside, and then here you've got 6. So you got 1, 2, 3, 4 right there. Okay, so all of those are possible choices for the number of graduation cakes. One, 2, 3, 4, 5, 6. Oh yeah, 7, up to 7. That's right. I did that right. Okay. So there you are. So all those are possibilities. Okay. If he wanted to, he could make what? He could make 5 of each. Nope. 5 of 5 graduation cakes, and he could make 4 wedding cakes. That's a possibility. He could make 6 of these, and 6 graduation and 3 wedding cakes. If he did that, he would use all the flour that was there. He'd use all the flour. He'd still have some sugar left, but he'd use all the flour. Notice right here, this is 4. This is 1, 2, 3, 4. Let me make those. These got shifted over a little bit. Okay, it's hard to do it exactly right. That one is right above this one. This one is over here a little bit. Okay, these are all in a line. Okay, those are all in the line. Anyway, those are all possibles. So he could make what? He could make four graduation cakes and 6 wedding cakes. That's a possibility. As I say, he could make 8 here. He could make what? 0 graduation cakes and 7 wedding cakes. That's a possibility. Then he would be right up here. These are all possibilities. So all those are possibilities. As long as he stays within this called feasible region, he's okay. So now here's the question. Suppose that he wants to sell the graduation cakes for $100 and the wedding cakes are also $100. Of all these choices, what choice should he make? So this is where Decimus is really handy, and I can't do it for you here, but this is where you need to use Decimus, and you can easily make these lines on Decimus, and then you can just do something like this. You go 100x plus 100y equals, write it equals p. Put it equals p, and then Decimus will give you a little, it'll say, do you want to let p vary? And it'll let you choose what values of p you want it to go between, 0 and 1,000, whatever you want. And you can choose the step size. And here's effectively what you're doing. What you're doing is you're saying this line, which is 100x plus 100y, is equal to P. I have R for revenue. You could think of it as P for profit or R for revenue. I guess actually it's revenue because he still has to pay the cost of the cakes. So this is revenue. What does this line look like? If you had 100x plus 100y, that's going to be a line with slope of -1, and depending on what R is, you are going to be moving this line up this feasible region. If R is equal to 0, this is the line you have. If R is equal to, I don't know what it is, 10 or 100 or something like that, it moves up, and it's going to keep moving up. It's going to keep moving up, and you want this to be as large of a number as possible. So you want to keep moving this thing up as long as you stay within this feasible region. And so notice I have only one point left in that feasible region, and that's the point 46. By the way, how did I get 46? Obviously I had to do that by finding the intersection of these 2 points, of these 2 lines, right? And I'm out of room, so I don't have too much room here, but let's just do it for the practice. If I have 3x plus 2y is equal to 24, and I have x plus 4y is equal to 28, what's the easiest way to solve that system? Let's multiply this one here by, let's multiply this one here by -2. Okay, if I multiply that one by -2, I'm going to get -6x minus 4y is equal to -48. Agreed? So if I multiply this by -2, I'm going to get that. And now I can subtract one from the other, and I'm going to get -5x. These go away. And here I'm going to get is equal to -20. So x is equal to 4. And once you have that x is equal to 4, then you can 4 plus 4 times what gives you 28? Well, it must be 4 times 7. I'm sorry. 4 plus 4 times what gives you 28? That means that 4 times something has to give you 24, which means that y has to be 6. So there's your point 46 right there. Okay, so we've got all the points of intersection there. Okay, so here's the point then. This revenue, you want this to be as big of a number as possible, And as this number changes, you can set it equal to 0 and you get this line. If you set it equal to 10, you get this line. Set it equal to 20, you get this line. And you want that to be as large of a number as possible. And it always has to stay within the feasible region. So it looks like the very last point in your feasible region is going to be this point right there. So it looks like that's going to be the best strategy, is to make 4 graduation cakes and 6 wedding cakes. Let's check it out. Okay? We know for sure, just because of this whole system, that you always want to push it off as far as possible, that it's always going to be on the edge. There's no reason to stop right there. You want your value of your revenue to be as high as big as possible, so you're always going to push it out to the edge. So sure enough, if you charged 100 for each one, and you made and you chose this point right here, which is 7 wedding cakes, you'd make $700. If you make 4 wedding and 4 graduation and 6 wedding cakes, you'd make $1,000. If you made all graduation cakes, this was all wedding cakes, if you make all graduation cakes, you're going to get 8 times 100 plus 0 here to give you $800. So sure enough, there's your maximum. Okay, that's the idea. So now let's change things a little bit. Suppose that we have $20 for a graduation cake. That's pretty cheap. And $100 for the wedding cake. Then, what should be the best strategy? Well, let's think about it. 20x plus 100y, that's, if you set that equal to some constant, and you solve it for y, that means that y is equal to what? Negative 20x plus a constant, negative 20x plus the constant, and then you divide through by 100, and that's going to be a slope of negative 1/5. Negative 1/5 is a very shallow slope. See that? It looks like that. So there's your revenue function right there. Again, we want that to be as big of a number as possible. So you keep moving that up until you come to the last point in the feasible region, and it looks like it's going to be right there. Let's check it out. It looks like it's going to be 0.7 is going to give us the best. Let's check it out. So now we're doing what? Now we're charging $20 for these. And 100 for these. So I still have $100 there. There's going to be 600 plus 80 is 680. And here you have just 8 times 20 is 160. See that? So now your best choice is this choice. It's to make 7 of your wedding cakes. See that? Let's try another one. Suppose it's 50 and 10. Suppose it's 50 and 10. Okay? So these are all now going to be $50. Well, let's check it out. We have to check all the endpoints. Actually, here's one more endpoint for your feasible region. It's the point 0, 0. It doesn't make too much sense to check that one because we know it's always going to give us 0, but technically that's one to check as well. But anyway, let's check the 3 that are going to give us non-zero answers. So if you put in 50, then what do we get? We're going to get 700 here. Here we're going to get 600 plus 200 is going to be 800. And here we're going to get 400. Okay? So it looks like that's going to give us the middle one again. Okay, does that make sense? We've got a slope now of, this is now 50. So it's negative 50 over 100, which is a slope of negative 1/2. Negative 1/2 looks something like that. And it looks like the last point we're going to leave is going to be that point right there. If you have a slope of negative 1/2, it's going to come up and going to hit you right there. See that? So sure enough, that's good. Let's try one more. Let's make it $160 for a graduation cake. I guess that would be a pretty fancy graduation cake. And if so, you have 160 here, 100 here, and so if you solve this for y, you end up with negative 160 over 100, which is a slope of negative 8/5. That's a large negative slope. See that? So you're going to have a large negative slope, and you ask, where will a line like this, as k increases, that slope is just going to keep the same slope. The slope doesn't change. It's just going to keep moving farther and farther away from the origin. Let me do it again just to make sure. So here the slope isn't changing. I'm just going farther and farther away from the origin. And see this? I leave this point behind, and the last point that I leave is this one right here. So it looks like if you charge 160 for the graduation cakes, you should be that should be the maximum. So let's check it out. You stick 160 in for the price of the graduation, still 100 for the wedding, and if you happen to be on this point right here, you'd make $700. If you chose this choice of 4 graduation and 6 wedding, you'd be at $1,240, and if you made all graduation cakes, you'd be at $1,280. So sure enough, that's the best one. So very nice. So this is, as I say, this is a problem that that they developed this stuff back in the 1940s, I think, and it helped us to try to figure out what's the best way to make supplies in order to make things as economically as possible. And so it helped with the whole war effort. Okay, an example of where mathematics helped with the war effort, and it's been helping people with production ever since. You can do these things in more than 2 dimensions as well. You can do them in 3 or more dimensions, so it gets more complicated. But this is the idea right here. And the key is that you're always looking for one of the vertices, one of the endpoints, because you're always going to push that thing as far as possible. So if you just check these 3 or the 4 to be thorough, to get all 4 of them, you know that whatever those 4 are, that one of those 4 is going to give you the maximum. Those are the only points you have to check. So, so there you go. So next time we'll get into counting, which is kind of fun. But this is the end of Chapter 8.